Algebra 2B, Unit 10, work leading towards Assessment 1. All right, to do this one, there are more than one way to do it. I'm going to say one way, but I'm going to do the other way. You could turn this into a proportion. What's a proportion? Is two fractions separated by an equal sign. If I were doing the proportion route, which I'm not, just so you will have heard it, you would cross multiply the 1 times this stuff and the 4 times that stuff, and then you have a long line of equations. I'm not doing it that way, but that's a common way that teachers would do. I'm going to multiply the 4 on both sides to get rid of the fraction over here, which is essentially the same thing, but by saying it, it'll sound something like this. Hey, Thomas, you got this problem here. You got the 4 on the bottom. Why don't you get rid of the 4? Old school style. Sure. To get rid of the 4, I do the inverse. Well, since 4 is dividing, I'm going to multiply a 4 on this side, which will make it cancel, leaving just the top, the 2x plus 7. But what you do to one side of an equal sign, you must do to the other. It's like parenting. If you do for one kid, basically you need to do for the other if they're close in age. Once they're not close in age, then that it's no longer true. As a matter of fact, some books say treat the older kid different than you do the younger kid. I'm going to distribute the 4 in here so someone can see that it's 4x and a 12, and I'm going to pause it just for a second so someone can listen. Yeah. We could have maybe done it at the same time. And then once we do that, then I'm moving things. So is this going to be on your test? Yeah, I think whoever made up the test from back in the day, she doesn't work with us anymore. I think she ran out of time, and she just like chose random problems because these problems have nothing to do with the next section. They just happen to be on the test, which is why I'm presenting them. But why this? In any case, put the 4. I'm gonna put the 2 over here. You do it however you normally do it. Normally put the next.
Did you not distribute the 2 to the 7?
Yeah, I did. Oh, and again, once I see all your work, just like I just messed up there, if you continue with the right work, even though you didn't miss one part of it, I'll probably still give you partial credit. They're probably worth 2 points on the test. And you will get half for the steps, and the other half is the correct answer. So what am I moving? The 12, I'm moving to this side. Sure, why not? The 14 was already here. I moved over the 12. The x's, the 4x was here already. I'm going to move over the 2x. And of course, my goal is to put all the same things on the same side. Like segregation, you put all the x's on this side, all the numbers on that side.
Just combine that too.
The only rule is once you move it, same number, opposite sign. Same number, opposite sign. And it won't always be subtract, sometimes it'll be add, depending on if it started as multiplication.
Wait, so if it's a positive, we have to subtract it?
So when if this were a negative 12, when I move it over, it'd be positive 12. It always has to be the opposite side of how it started. I'm going to pause here for a moment. So some of you are feeling, oh, this is sweet. For the last unit, they're going to give me like 3 points. Yeah, I consider these 3 points for you. All right, well done. This missing go, actually, no, you don't need those because, yeah, this is, you need this handout. Shoot. Grab one of those, not the top and the bottom one. All right, due to technical difficulties, I'm redoing this guy. You can take a mental break. 16. All right, 2.25, I guess, would be acceptable as well in case for one reason or another you did that. What I would like on this one, though, even though you could do it in the calculator, dividing 81 by the 16 before you take the square root, I do want you to write the fraction version if you can. And then if you want to go to decimal at the very end, do that. All right, number 5, I think it's just combining like terms. So I'm going to try and get through these quickly so I can get to the new stuff. This is just so you have something to be reminded. No? All right, here it comes. Hey, Fiverr. So here, in the world of math, I dislike these because they mess up students. And when you make one mistake, the rest messes up. Obviously, it won't mess you up. But here's the deal. If you are in a parenthesis, whatever happened to you on the outside affects everybody in there. I'm sure there's some analogy I could make that would make it interesting for me, but it would take up too much time. So I'll just say this negative sign says whoever's inside here, I'm going with jail. Jail is a negative place. You went in as a nice person, like Orange is the New Black. The lady, she's a nice lady. I haven't seen all of it. Just sort of the beginning. I assume by the end she becomes hardcore. I assume that. I may watch some of it, though I fear some of it might not be appropriate for me. So you need a computer. There's only that one sheet for the new thing. So here, negative x squared. You're positive, now you're negative. The next, most students always change the first piece. Is the other two pieces they don't change. It changes to the opposite sign, not just negative. That is, if it were a negative 4, it becomes a positive 4. I'm reminding you something you already know, but here we go. And the negative 8. Why is he messing around with that first? Because over here, if you're inside and there's nothing out front, a positive sign, it just says you stay exactly the same. In other words, if there's nothing out front, you just tear off the walls and you stay the same. Here's the beauty of this one, and I can't imagine why they're putting this on a test. Even I'm slightly offended by the ease of this one. I just combine like terms. If I had the power of colors, I would make these two, the x squares, I'd make them red. The middle guys, I'd make them blue. And the last two guys, I'd make them some other color, and we'd combine the colors. In any case, if I have 3 x squares, and I take away one of those x squares, obviously I'm only going to have 2 of the x squares. If I have 3 of these x's, and then I took away 4 of them, how we do that in real life, we don't know. We wind up with a negative 1 of those x's, which of course we're not going to write the 1. Everybody has just negative x, but. And then lastly, if I had negative 5s, I don't even know what that means, and if I owe $5, then I borrowed 8 more, how much money do I owe altogether? I owe $13, like someone I know who owes, well, whatever, I'm recording. I'm going to rewrite it just for state test purposes. Oh shoot, there's more we got to do. So I'm going to keep it this way. The instruction that they say solve for x. Go to the very top and say solve.
Yeah, solve.
All right. Unfortunately, then we have to use a quadratic formula because this little 2 here. Put it in once you get it in. Depending on how far you go, I'll determine how much you need to do. I'm trying to do as quickly as I can. Here we go. There's a bad boy. Wasn't sure if he was going to go to the house party. He got that there were drugs, and he doesn't take drugs. That makes him a square. And therefore, he missed out on 4 awesome chicks who were clearly on drugs. So they weren't really that awesome, but for the story, we'll make them that. And the party's all over at 2 a.m. So let's label over here who's A, B, and C. I don't remember the last time we did this. A is going to be a 2. It's the number in front of the square. B, it has to be a negative 1. You don't just take the number, put the sign, and then 13 for the C. If I didn't pass out calculators, it might be appropriate for these, even though I think Scott might be given out to everyone except somebody who he didn't like. Let's see. So if you don't have a calculator, all right, now I'm getting late. All right, so I'm putting them in. I do want you to do this for me until I know you might be super expert. On this next line, where you're going to put things in, please put a parenthesis for any of the letters, like B minus B, make it a parenthesis, plus or minus, house, parenthesis squared. Minus 4, parenthesis, times parenthesis, all over 2 parentheses. Why is that important? Just because sometimes some people mess around that first B. If B is a negative 1, they'll make that outside negative just as a regular negative 1, when the truth is, the outside says, I want the opposite. That's what the negative sign represents in English. I want the opposite of whatever B is. Oh, B is a negative 1? Okay, it's going to be a regular one when I finish with it, but I can't do other colors to this thing. Forget it. I'll just go. B, where are you? Negative 1 in here. A, you're a 2. And then you're a 13. So just get headsets there in the back under the table. And then the 2. I'm going to see if I can do one more line. I'm going to try and get a single thing under the house. Once there's a singles, if it's a perfect square, go all the way to the end. If it's not a perfect square, then you can do there. Probably need a headset. Max is on the table in the background. So let's see. If anyone's gone further, what does under the house equal? It's a 4. I'll finish it. Yeah. Wait, finish it in 2 minutes. Tick, 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 tick. Can I write on this thing? No. All right, here we go. 1 plus or minus. Got to write small. 1 all the way across. Oh, why don't I start? No, they don't have the space. I'm gonna do it over here because I have space. You put it down if you can. Well, let's see. Plus or minus. There's a 1. You're what? 8, 13. You're 26. Thank you. It's 105.
No, I mean it's 104 plus 1.
104. And 105 is a perfect square, so it's going to stay in the house. All right, so then I'm going to leave this as 1 plus or minus 105, radical 105. All over 4. If your teacher, if your future teacher presses you on getting the final line, and then say that. All right. These two only go up to 10, correct? It doesn't go past 10. Proportion of any two fractions. I don't care what's on the top, what's on the bottom. As long as there's two guys who want to fight, and their friend is in the middle breaking it up, there are proportions. I don't know if you've ever done it. I do it once in life, not that I don't do it. Once in life. Of course, there's that other person who's going to push one of the guys because he wants to see it go down. All right, so here it comes. Cross multiply. All right, here we go. A negative 4 is going to be in front of the x minus 6. I'm going to do this in my heart. I feel like you know how to do it. Just so it can be on the notes, it can be on the video. Some kid maybe dropped out of school in like 6th grade and then kind of came back in and you missed it all. You distribute for that minus 4x. I'm just doing just to have it in the thing. 2x and a 6. For me, I'm going to put the 2 on this side, the 24 on that side. The negative 4x is that the 2x. The reason I started doing the move it system, that officially I'm supposed to subtract negative 2 from both, subtract 2 from both sides, and then subtract 24 from both sides. I switched over to this method of just moving things over. I used to teach junior high. Some kids just didn't get it. They'd mess up on the subtracting part. But any kid can take all the x's and put them on the left. Any kid, no matter if you don't know your timetable, you can put the constants, the regular numbers, and put them on the right. And so I was teaching for any kid, not for the smart kid. In any case, when you move it over, same number, opposite sign. Same number, opposite sign. And at this point, the kids who didn't know math, they couldn't go any further. They don't know what 6 minus 24 equals. But at least they had the setup right. Someone say out loud 6 minus 24?
Negative 18.
Negative 18, and then someone say out loud negative 4 and a negative 2. Yeah. And some people on that, they still would put that 2 on there. They don't, that whole thing. All right, then divide that 6, we're all done. And it should be a 3. I hope you can see why I know whoever made this test. You need to. We don't want to work with a fraction. How do you get rid of a fraction and then an equation? You multiply everybody by that denominator. That is, I'm going to multiply the whole thing times the denominator, which happens to be an x. It's going to hit you, it's going to hit you, and it's going to hit you. I'll say it 2 ways. X times 3 is 3x, divided by an x leaves you just a 3. The other way of saying it, the first one, the x's cancel, leaving just a 3. I don't know how you're going to get it, but see what happens. X times an x is an x to the second power. That is, there are 2 of those x's. And then x times a 9 is a 9x. Really? What if I go backwards? All right.
And so we just put an x on the end and distributed it?
Yeah.
Okay.
From there, we're going to move everybody to the side that makes the square term positive. Once the square term is positive, then I'm going to go ahead and do the quadratic formula. Therefore, this guy here, well, both of you are going to have to go to that side of the room, leaving a 0 over here. That is nothing. The 9x, I know you were here at the beginning, but so let things be in the right order. The x squared will be at the beginning, same number, but the opposite sign. Yes, 9x, you were here, but you're always second. And the 3, of course, you go to the end, same number, but the opposite sign. Take a look at it while I write down my ABC. Because they want us to solve these. Oh, shoot. Let me see what it's number that when you multiply them give you a 3, but when you add them give you a 9. Yeah, we gotta use the quadratic formula. Without a number in front of the square term, you could have maybe done the big X thing.
Why did you put zero?
When you move everybody to the other side, technically what you're doing is you're subtracting a 3 from this side. 3 minus 3 is 0. And you're adding an x squared on this side. X squared plus x squared is 0. So technically when I just move everything over, the nothingness there has to technically be replaced by a 0. This thing over here won't work. They're not two numbers that if you multiply them give you a 3. Okay, you get a 3, it's 1 times 3. It's not going to produce a 9. That's kind of how you know, shoot, I got to use the quadratic formula. But again, you don't even have to guess that. You can just go straight quadratic. You plug it in, you multiply it, you're done. Let's see, you're a 1. The A is always the number in front of the square term. The B in terms of the linear, and C, A, B, C. Don't put in the letters like some students like to do. But again, you're at the last semester of algebra, therefore you probably wouldn't do that. There's a bad boy. He was in charge of going to the house party. He got there were drugs. He was a square, so he missed out on 4 articles of the Constitution. He's a reader. How about that? It doesn't have to be like he's chasing awesome chicks. Oh, he missed out on 4 awesome chairs. Yeah. 4 antique chairs. He was a collector. All right. Minus parenthesis, plus or minus radical parenthesis squared, minus 4 parenthesis, or parenthesis, if you need to spell it, and then 2 parentheses. Plug them in. Let's see if the house turns and whatever finishes fun in 2 minutes or less. And what you got here? B, you're a 9, 9, 1. Like any formula, I hope you feel that the quadratic formula, if you go on to pre-cal and go on to college, any formula in any class is all the same. It's a bunch of letters. It's a puzzle. You write out the puzzle, find out the pieces, and plug them in. Usually one piece is missing. In this case, we got them all. Let's see, you're negative 9 plus or minus. Shrug is 81. 81, that's a 12 plus 12. Hey, remember this. When you multiply this 4, it's a negative 4 when it's being multiplied. Another way of thinking of it is if there are 2 negatives, this little line is going to be plus something. If all 3 of them were negative, it would be a minus something. All over something. 2, 1. Shoot. All right. 81 plus 12, anybody know? 93.
9. Oh, yeah.
Say it again.
Wait, plus?
Yeah, it looks like a plus. Yeah. So it looks like it's going to be, 93. So we're done. Radical 93. All right, that's it for this section. Yeah, so this 9 should be negative here.
So that's how
Oh, that's sweet. But no, Skylar, what I pointed out, should be a negative 9. So if you don't have, we're dealing with statistics again, which is where it should have been. That's what we left off in the last one with standard deviation, that kind of thing. Hey, Danielle studies for almost every test. The probability of her getting an A on her test is 70%. Circle that 70%. That's going to be important. The following simulation was made to represent 15 tests. Each number represents one of the tests. How often does Danielle have a streak of 3 or more A's? Circle that on each test row. So each row goes from left to right. Column is up and down. Row goes from left to right. They're trying to figure out what are the chances that she has 3 A's in a row. All right, let's see how I can say this. I know to do these simulation problems, you're going to start by writing out the numbers 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Dang it. The next thing that I need to do is check my sheet because we are going to take a lot of stuff you just said, but let's be hot of it. But don't worry, no worries. Only one person may watch these, and basically I don't think that person does. So no worries there. All right, let's do this side, and then one all together. This side, yes, all A's, or no, all A's on this next one. All right, yeah. Over there, next row, all A's or no?
No.
Yeah. Oops, that's what I wanted. And then the bottom one, yes or no?
No.
Once you do this, you're near the end of the answer. You're trying to find out what percent of the time does she get all A's. And so you do the time that she gets A's over how many possibilities there are. The rows tell you how many possibilities. So out of the 5 rows, 3 of the rows get us what we want. And then what percent is that? It happens to be 60%. I'll do a decimal for it first, for the student who's forgotten. 3 divided by 5 is that. You move the decimal 2 times, which gives you the 60%. All right, here we go. I'll have to talk about a party here and a bouncer, and creepy dudes and kids that are too young to go to the party. So let's see if we can talk about that while also actually doing the math. Hey, a certain 8 seniors at Algiers at A high school found that 65% had been accepted to a 4-year university. Turns out that 65 may not matter. Let's put a question mark on that one. A computer simulation was conducted and the proportions sorted to determine the sample-to-sample variability. All this is like a bunch of talk. Let's see what it says. A proportion of students attending 4-year university sorted by the simulation. Let me go down to see what one of the questions are before I start telling you the steps to get it. And the steps are no big deal. If you can count to 10, actually if you can count to 5, you can get most of this answer. All right. Question A, find the upper, that's important, and lower, that's important, 5% circle that, bounds, that's important, of the sample-to-sample variability. If they give you 100 numbers, this is way easy. If they give you less than 100, you got to think, but we'll always be doing it as if there were 100 there. Let me see what the second one says. Predict the proportion of seniors at Algiers that have been accepted to 4-year universities and give them a, this is going to be important, a margin of error, M-O-E, margin of error. What we call that, your MOE? That way you don't have to say the whole thing every time. All right, so let's see if we can get them what they need. Okay. Upper and lower bounds? No, it can't be that easy. Yeah? Dang it. Whatever. All right, here goes. If you have 100 numbers, first they need to be put in order from least to greatest. And you'll see these numbers going down, 51, 52, 54. They're in order from least to greatest. Okay. To find, in 100 numbers, every number is a percent. 1%, 2%, 3%, because you're out of 100. The question down below, and I can get it where I can have it there, wants you to find the upper bound and the lower bound at 5%. Perfect, got it. Here's what that means in English. Lower bound, those are the smaller numbers. Upper bound, those are the biggest numbers. What we're going to do is we're going to go in 5% from the little kids, and then in 5% from the big kids. Whoever is the 5th guy in, he's 5% away from, let's say it. Watch this. 1, 2, 3, 4, 5. Don't be confused anymore. The words of explaining some math is harder than the thing you're doing. Hey, Thomas, what's the 5? 1, 2, 3, 4, 5. Each one of these groups, this top one and this bottom one, represents 5% of the total, 5 out of the 100. The last guy in the group, starting from outside going in, is called the bound. He's the lower bound of 5%. He's the upper bound of 5%. Lower, because he's a small number. Upper, because he's of the large numbers. The question over here is, well, what's the answer? Here's the answer. This number here, we're going to turn it into a percent, and he will be the 5% lower bound. We're going to turn this number into a percent, and he'll be the 5% upper bound. So let's see if I can turn those into percents. They'll see the answer. This may be one of those things where, like, I'm not quite sure what it even means, but I can get it. The lower bound, you are going to be 56. Sure, I'll just put in the percent right away. I'm going to put it over here and turn it over, and the other guy, the upper bound, you're going to be 74%. Let me put the 0.56 to remind someone why it turns into 1, 2. Why it turns into a 56. And then the other guy, of course, same thing. And those two, they go there. Hey, I got 100 numbers. How do I find the upper bound, lower bound? I count in 5 if they're in order. Count in 5. I'm there. Everybody else in between, you are the 90%. If this were a party, everyone gets to come to the party, except for a few people. The really little kids, if you're too young, you just can't come in. You can't come into this place. As a matter of fact, the lower bound is the protector of the door. You 56, we wish you could come in, but we're going to have you outside the door. Don't let anybody in, okay? We're going to have a good time in here. You'll hear it, but you can't come in. On this side here,
like the other 56.
I know, well, yeah. Down here, these are the older kids. It's a young person's party. It's a teenager's party. There's some dude. He's like all like 25. Like, can I get in? Like, no, people are 16 in there. Like, yeah, but that 35-year-old, he's trying to get in. Yeah, he's creepy too. So here's 74. You're the upper bound. You keep the creepy people from getting in. Yeah, I know that guy is creepy, but he's cool. Or he's
the chaperone.
Yeah. This dude is trying to get it for the wrong reason. That guy is like, all right. So let's see what the next question asks and see how we can put this thing together. So we're going to turn this checksum, this total, into a percent.
0.6464.
Oh, okay. So, yeah, it does just move it to it. This is going to be the worst thing that I've ever done, but it has to be done.
The worst thing is probably sitting for target.
The problem is going to be this. After we turn this into a percent by comparing it to 100, we literally actually have to turn it back into a percent. So we turn this number into a decimal by dividing by 100. To turn any decimal into percent, you know what you do? You move it 2 places to the right and add a percent sign.
Promise, like, can't you just skip?
You could. The reason I'm showing that step is, again, this is the easy version of it, where they give you 100 items.
Yeah. Oh,
They could give you 20 items, which they try to do on another problem, and now you're dividing by 20 to turn it into a percent. But that's what I really should say. You're dividing by the total. In any case, what do you do after you get this answer here? You're going to do some subtracting with that. So the next step, you are going to do, and they rounded it. Okay, I'm going to round it too, because on my answer key they rounded it. All right. We're going to compare this to the high and to the low. So we're going to take that 65, who is going to be bigger than the low. And we're going to take that 65, who's going to be smaller than the upper bound, 74. After you get all the things, I'm remind you of the steps so that you can be like, okay, I see that, I see what we did here. Keep your whys to yourself, initially just follow the steps. So we're going to compare this number here that we got from doing this here to it's bigger than the low, and it's smaller than the high, where is it? the upper, and we're going to do a subtraction problem. If we've done it correctly, this subtraction problem should produce the same exact answer. So we may know that 65 minus 56 happens to be a 9. And the 74 minus that also happens to be a 9. The question is, what is that going to give us? I got to see. What that's going to give us is the possible error. In other words, let's see if I can do this. Let me write the final answer so they can see it. All right. Take a look at that answer and tell you where the numbers come from. And we'll track it, and we'll give the right words that go with this. All right, let's see what they did now. Got it. Under this 100 over here that we did some division, write the word mean. I get what I did. Okay. And then we'll put it all together. Here we go. Some people start writing, give them a chance to write. This top section, when we divide by 100, I mentioned percent. I should have mentioned finding the mean of all the numbers. Find the average of all the numbers. If there are 100 numbers, you divide by 100. If there are 20 numbers, you divide by 20. There were 100 numbers up here, so we divided by 100. Once we got the mean, we had to turn it into a percent, which gave us this thing here. Once you have the mean, you have to find out the margin of error, which is this thing here. How do you find the margin of error? You compare the mean to the lower bound, and you compare the mean to the upper bound. Once you compare them, that is, you find the difference, you'll get this special number here, which is a percent. And the rule will simply say this: in your bag of chips, on average, you're going to have 65 chips in your bag. In this problem up here, they have a margin of error, a MOE of 9. In other words, you can have 9 above, and you're cool. You can have 9 below, and you're cool. So you get, what's 9 plus that? You have 74. Or you can have 56 in your bag, and you can't sue us. You can't. Our machine can be off by 5%, and that's okay. Pause. Comment on the front. You're given a certain amount of numbers. If it's 100, you count down 5 to get the lower, count up 5 to get the upper. Once you have those two things, you write them as percents. Once you have those two guys as percents, step 2, find the mean of the total amount of numbers. In other words, if there are 100 numbers, we divide it by 100. If there were 50 numbers, we would divide by 50. Okay. Once you get the mean, you have to write that mean as a percent. Once you have that mean, you have to compare it to the lower, compare it to the upper. After you do that, it gets you how much you can be off. You can be off by 9%. This is a percent. To give you the final answer probability, you got to give the mean and the MOE. The mean and the MOE. MOE, margin of error, you can be off by 9. Those are the steps. You can, here on number 3, there are only 20 numbers. So part of it we're going to do wrong, but I'm still going to have you do it wrong, and part of it we'll do right. We need to get these numbers in order from least to greatest, so that we can count in 5 this way to get the lower bound, and we can count in 5 this way to get the upper bound. Once we do that, and we are going to do it together, I just want to say to you so you can feel it with a smaller number. You're going to get the mean of all these numbers. You're going to divide by 20, whatever the total is. When we add all those numbers together, you're going to divide by a 20.
We have to add all those numbers up together.
To get the mean, you add everybody together and divide by how many there are. Oftentimes they'll just tell you. I don't know. No, they didn't tell you this time. Once you get that, then of course you're going to compare the mean to the lower bound and the mean to the upper bound for the subtraction. Again, we're going to do this, so I'm just saying so you can feel that it's doing the same thing as the last thing did, just with less numbers. Once you get each one of these, this will give you the MOE, the margin of error. And then your final answer is going to be the mean plus or minus the MOE. So say it again to them. Count down to get the lower. Count up to get the upper. Once they get those two, get the total. Divide by the number there is, in this case 20. Once they get that, which will give them the mean, they'll write it as a percent. After they write it as a percent, they'll do two subtraction problems to get what we call the MOE, the margin of error. Once they get those two numbers, they're done. They have a mean and they have a MOE. The mean plus or minus the MOE. So get the mean by dividing, get the MOE by subtracting, and then do that. The only thing else I'm going to say on this one before we put the words yes or no at the bottom of this page is this. Technically, because they're on 100, you know when they do it like they're 100, you wouldn't count in 5 on either side. Technically, we're doing it properly. We would find what number is 5% of the total.
Should be 1.
Yeah, so it'd just be 1 digit at the top and 1 digit at the bottom. But because the pattern we want is 5 for 5%, we're going to do it fake, the beginning part. And then later on in life, if you had to do it the official way, we do it that way. And when we do it the real way, numbers don't work out quite the way you want to. All right, pause. These 3 pictures represent a machine for the company that you own. You own the chips company, the Cheetos. Your machines need to basically put just about the right amount of chips in those bags. The green line is the mean. That's about the amount we want your machine to put into the bag. The top red line represents the upper bound. In other words, if your machine, you'd be upper, oh, really? What did I do? And can I stop recording while I'm doing it? And I can't even get to the top thing to undo it. To go back, press right click on. All right, let's do that. No way. If you're now watching this video, there's a storm happening here in Fontana. If I were me, I would hit you again. Close enough.
It's up there.
You see it?
Top left.
Again? How do you get over there?
Because something can come.
All right, all this just to get to erase is what I really want. Slow, okay, fine, I'll go slow. The top red line is the upper bound. Your machine better not make more chips than that too often, or we're firing you. We've contracted you. This is the lower bound of the red line. Looking at a picture, here's the question. Hey, is your machine working right? If all the dots stay within the upper and lower bounds, yeah, your machine is good. This machine is a yes. Your machine is good. Do me a favor, take a look at the other 2 machines, decide whether those machines are good or need to be fixed. They're a yes or a no. Will they put a question like this on the test? Believe it or not, they will put a question like this. They may ask you to label it too, though. The red line is upper bound, lower bound. Eventually, we may actually find some numbers. All right, once you put in a yes or no, this side of the room on the second one will ask for yes or no. The third one will ask for yes or no on that side, and that will be it in terms of the deal. Hey, on this side here that has Angel, Nadia, and the crew, is this a yes or no? Okay.
Is it a no?
It is a no. How can you tell?
Because
Yeah. Because this thing gave too few chips, you're gonna get sued. So no, take that machine offline. We don't want that.
What if it touches the line?
On this side, you get to go to the upper bound. You can go all the way up to 9 chips more. So on this one here, yes or oh. Over there, oh, that guy over there.
Yeah, when it touches.
Yeah, so he's okay.
Okay.
But the lower guy messed the machine anyway. How about this one over here? Yes or no?
Yes.
All right, they got it. So, papers on the back that might lead to I did also grade everything last night. I graded as if it was all addressed. So if obviously you weren't, so I gave her that. So again, those are,
On the key,
what did you say? That one.
can you do it when to choose landing?
Yeah.
Wait. More.
Could you go?
And yeah, it looks like right. So it's not like if you prefer the arithmetic. Oh, I'll do two things of that one for Jim. I'll do two things of that. So let's see what we have here. Yeah. Right. So the plan right now is just for everyone to be aware of, okay, what do I need so as I plan? If I'm doing something tomorrow, at least I know what it is I'm looking for. I give you a test one, just remember. I test one, so you put your name also that one exists for you. Yeah, you'll start there on the back, look to see anything that you don't currently have in that stack. Put those in, and then that way when you start checking the videos, you'll be able to see, okay, I have that. 0991.
So these two don't have
You are correct. Only the dashes are missed, and then very bottom, it should add up to the dashes that are above. One there. So Randall, put a test one on yours. That way you put your name at the top. Tomorrow, 9 to 11. And then one, and that's two. Anybody not have, you haven't addressed both tests, you've never gotten both tests. Okay. Everyone should have. Yeah, you need one of those, unless you have it. Anything that's back there, we can pass out to down. And then, once you start scrolling through the videos. I'll start the same. So again, right now you're planning, you're looking, you're checking to see what you'll need. And if you take anything, I'll take from below that way. So I have the title. None of those should say keys. And when you get a chance, later to come back here with Randall, to grab any papers that you may not have from, well, you may not have. I was taking the highlight stays on there. It would be 9. The next chapter will be on this. And let's see.